Hello everyone, welcome to Chemistry Guru once again. In the last video, we discussed about the set of points in an Argand plane, and we discussed about the equation of a circle in complex form, which was of the type z minus a mod is equal to some constant, let us say r, right, where that r is the radius and the point a is the center of the circle. Let us discuss some more examples on the set of points in a complex plane. So next example is that we have to draw on an Argand diagram showing the set of points z for which z minus 3 minus 4i mod is less than equal to z plus 1 minus 2i mod. Whenever we see any kind of equation of the type, let us say z minus a is less than 2, right? Whenever there is an inequality in the given question, so first thing we will do is we will remove this inequality and replace this with an equality sign. Okay, just to understand what will be the boundary, right? What I mean to say is boundary is that if I say that z minus a mod is equal to r. So in the previous video we discussed that this represents a circle with center a and radius r. A means it is another complex number of the type x plus iy type, right? So this represents only the boundary of the circle, right? I'm not talking about the region which lies inside or outside the this circle, right? So this is because we are talking about equality. We are talking about all the points which are lying on this circle, right? Following this condition that the distance of this z from a fixed point a is always equal to r, right? So we arrive at the boundary of the circle, right? But if I replace this equality sign with an inequality sign, for example, let us say less than equal to r, so that represents the points which include the circle. This is because of this equality sign, and less than means all the points which are lying inside this circle, right? So that represents the region which is you can denote by capital R, such that it represents all the points which are lying inside and on the circle, right? Similarly, greater than equal to R will represent the points which lie outside this circle, right? So as in the simple, you can say simple real numbers, if I say x is equal to 2, so this gives you a particular solution of the x. But if I say x is greater than 2, so you get the range of values of the numbers, right? Similarly, we have, if in case of complex equation or complex inequality, so less than equal to r means that it gives you a set of points which are lying inside this region R. Fine. So this time we do not have the equation or the inequality of the type mod of z minus a is equal to r. There is another complex number of the type z plus 1 minus 2i, right? So what kind of you can say geometry is represented by this, right? So let us do this. So here I have z minus 3 minus 4i. So first of all, my first step here will be that I will remove this inequality sign and replace this with an equal sign, just to understand what kind of geometry is this. So this is minus 2i, right? Taking out minus sign, so I will get z minus of 3 plus 4i modulus is equal to mod of z minus 1 plus 2i, right? So that means in an Argand diagram, I have this as the Argand diagram, and there are 2 points. One is 3 and 4. So this is 3, this is 4. This point, this is let us say this point is A, which is 3 comma 4, right? This is 3 comma 4, and second point is this is minus 1. Sorry. Okay, this is z minus of minus 1 plus 2i, right? And there is another point which is minus 1 plus 2i. So minus 1 is there, plus 2i is here. Okay, so this point is B, which is of minus 1 and 2 type, right? So now I can join this A and B. right? So now this z is moving in such a way that its distance from two fixed point is equal, right? So if I move like this, suppose there is a point which is lying here, okay? So its distance from this B is less than the distance from this A. If I move in such a way that its distance from point B and from point A are equal, so this basically represents a perpendicular bisector, right? So if I draw a perpendicular bisector like this, okay, if I draw a perpendicular bisector, this red line, so you will see that if all the points of z of this complex number or all the points which are lying on this perpendicular bisector will fulfill this equation, and what this equation says that the distance from this point A should be equal to distance from point B. Otherwise, if the point Z is lying outside this circle, this straight line, means it is not lying on the straight line, then this distance will not be equal to this distance, right? So if the distance from the two fixed point has to be constant, that means that represents a perpendicular bisector, right? If this is just a constant, that represents a circle. If this is z minus a mod is equal to z minus b, and that represents a the equation of a perpendicular bisector, right? Now original question was that instead of equal, it was less than equal to. So it simply means that all the points z, all these points z, they are lying in such a way that the distance is less than distance of the points from this 3 comma 4 is less than the distance of the point from minus 1 comma 2, right? So all the points which are lying on this side, on the right hand side of this perpendicular bisector, will satisfy this inequality, right? If any point, let us say if there is a point here which is, let us say, P, so its distance from point A is greater than the distance from point B, so you won't, this point Z will not be in the Argand plane or will not satisfy this inequality, right? So all these points which are lying on the right hand side of this perpendicular bisector will satisfy this inequality. Okay, so you just shade the portion which is lying in the right hand side of this bisector. Okay, the shaded portion is the solution, right? Let us take another example. It says that draw an Argand diagram showing the set of points z for which z minus 12 plus 5i is less than equal to 7, right? So again, this represents a circle, and all the points which are lying on the circle whose radius is 7 and center is 12 comma minus 5, plus the points which are lying inside the circle, because here it is less than equal to, it is not just equal to, right? This we have already discussed just now, right? And second part says that use the diagram to prove that for these values, for all these z points, the maximum value of z from the origin is 20 and least value is 6. This we have to show in the diagram only, right? So let us solve this, right? So I'm writing this as z minus of 12 minus 5 times I, and replacing this with an equal sign which is 7, okay, just to sketch the circle, right? So there is a point 12 comma minus 5 which is the center and radius is 7. So let us quickly sketch this. Okay, I'm saying that this x coordinate is 12 and y coordinate is minus 5. So roughly, if I'm saying that uh, this is 12 and this is minus 5. Okay, so I'm taking this point as the center, right? And let me draw an exact circle here. Uh, yes. since the radius of this circle will be 7 and this vertical distance from this point with the x-axis is 5, so I need to take a bigger circle, right? So let us take, for example, this is the right? So this is your circle, and this center point is 12 comma minus 5, right? This distance, vertical distance is 5 and the horizontal distance is 12. Okay, and this is your origin, right? Now it is asking, right? This we have shown, okay, and since inequality is there, so all the points which are lying inside this region R will be the solution, or it is just a representation of all these points. So you can shade this region. Okay, I'm not shading because the second part I have to do and I have to remove all these shading, right? Okay, so now second part is use a diagram to prove that for these points mod z is lying between 6 and 20. So let us interpret what this inequality says. So it says that if I'm removing this 6, so I just write mod of z is less than equal to 20. So it simply means that again it is representing a circle whose distance from the origin is 20. Okay, if I write this as z minus 0 modulus is less than equal to 20, so it means that the maximum value of this z, which is a circle, right, its maximum radius will be 20, or simply that magnitude of the point or the distance from the origin will be 20. This is the maximum distance. Okay, and the least distance should be 6. Okay, so basically we have to find out the distance of this point z from origin, right? Because I have to find out mod of z. Okay, so this is my origin. Let me choose another color, right? So if I follow this line, right, since as you can see that all these points z are lying inside the circle and all or on the circle. So if I take, let us say for example, this distance I am taking. Okay, so this is your point z whose distance from the origin is this distance, right? And if you take the point inside the circle, that will give you the value larger than this value because you are inside the circle, right? So first we are talking about the least value, right? This 6 we have to show, right? So minimum distance will always be in the line joining the origin towards the center, right? So if I draw this straight line from the origin, which is following this distance, that it is following the radius, right? Not along any other line, but from which is passing through the center, right? So if you take other distances, if you take all these distances which are not lying on this line, those distances will be greater than this distance because it is lying along the tangent, not along the tangent, but if you draw the perpendicular here, so this distance will be the least distance, otherwise all these distances will be greater, right? So perpendicular distance is the shortest one, right? So this distance basically we have to calculate. Right, now let us find out the value of this perpendicular distance, which is OP. For example, name this point as P, right? So OP is the least value, and let us find out this. So this horizontal distance is 12, right? This vertical distance is 5. So in this triangle, if I apply the Pythagoras theorem, this distance O with this point center, let us take this point as C, right? So this distance OC is 13. Okay, and as the radius of this circle is 7, so this distance is 7. So OP will be OC minus PC, which is the radius. So OC is 13 and PC is radius, which is 7. So the distance OP is 6, which is the least distance of mod, right? All other distances of Z, all other distances of point Z will be greater than this 6, right? Now let us come to the other part, which is the maximum distance, right, from the origin. So if you take any other point, let us say you are taking this point I hope you can see on the screen this point, let us say R. Okay, so the distance of this point O from R, distance of point O with any other point which is not lying on this line, which is passing through the center, right? All these distances will be this time less than the distances which are lying along the line OP or OC, right? So you can extend this line like this, right? So this distance will be the maximum distance, because all these distance, if you see clearly, these will be the least, right? Maximum distance will lie along the diameter of this circle, right? Along the diameter of this circle, right? So basically we have to find out this point, this distance, which is OQ. Okay, so it is again very simple. This OP we have calculated, this is 6, right? So OQ will be 6. OQ will be 6, which is OP, plus PQ, which is the diameter, right? So this is 6 and diameter will be 14. So this is 20, right? So maximum distance you have shown is 20 and minimum distance you have shown, which is 6, right? I know that this is quite not that easy. I won't say this is too difficult, but yes, it is slightly different from what we have or we are doing in vectors or in coordinate geometry, right? We have to just analyze the uh, complex number, analyze the point, and just find out the distances. Okay, and definitely you will be able to find out the distances. Some distances will be given in point form, right? So you have to apply some Pythagoras theorem, but this is not that too difficult that you won't be able to uh, see, or you won't be able to calculate this distance, right? So let us solve another question. This time it says that on an Argand diagram, show the region R for which, again, this is again a circle with center 5 and minus 4i, and this is its radius is 3. So let us quickly sketch this. This time it is 5 and minus 4 and radius is 3. Okay, let me, this is 5 and this is 4. Okay, so this is 5 and minus 4, right? And let me take a circle. Since its radius this time is 3, so it will lie in the 4th quadrant only, because this vertical distance is 4. Okay, vertical distance is 4 and radius is 3, so it will not cross the x-axis, neither it won't cross the y-axis, right? Because radius this time is 3. Okay, so this is your circle, right? So it says that find the greatest and least value of z minus 3 plus 2y, right? Greatest and least value of z, since this z represents all the points which are lying inside this circle, and this circle is your R. Okay, first part basically saying this, that we have to show this point, the region R is all these points which are lying inside and on the circle, right? So all these points, the distance of all these points from the point this time is not origin, but the point is 3 comma this is 3 minus 3 comma 2i. Okay, minus 3 and 2i. So minus 3 point is this and 2 point is this. Okay, so this distance is 3, this distance is 2, right? So, and just analyze that we have to find out the distance of z which is moving inside and on this circle. So as in the previous example we did, that the least distance will be along the line which is passing through the diameter, and along the same line you will obtain the maximum distance, and it will lie on the other side of the circle, right? So this point, if you are watching this closely, this will be the least distance of the z from the point 2 comma 3, and this will be the maximum distance, right? So let us draw this till here to find out the least distance. Okay, now this is 3, this is 2. I can find out this distance according to the Pythagoras theorem. Excuse me. 3 square, which is 9, 4 square, 2 square is 4, which is 13. So this is root 13, right? And this horizontal distance is 5. This vertical distance is 4. So this distance, let me draw this using the dotted line, right? This radius is 3, right? So this is 5, this is 4. So this is your origin and this is the center C. So the distance OC is 5 square plus 4 square is 25, plus OC is 5 square plus 4 square root. 25 plus 16 is 41 root. Okay, this distance is root 41, right? So from this root 41, if I subtract this is P, if I subtract PC means 3, you get the least distance, which is root 13 plus OP, right? So OP will be root 41 minus 3. Root 41, which is OC, minus 3 is the radius. So this is your OP, and the least distance is, you can write down least distance is OP plus, let us say this point is Q plus OQ. OP plus OQ, right? So 41 root minus 3 plus OQ is root 13, right? So root 41 plus root 13 minus 3. This is the exact value of the least value, right? And the greatest value will be if you extend this line like this. Okay, so in this OP, in this QP, if you add the diameter, which is 6, right? So if you this OC is root 41. In this root 41, if you add this 3, you will get OQ plus 13, right? So this is root 41 plus 3 and then OQ, which is root 13. So greatest distance is QP, or you can write OQ plus OC plus the radius R. OQ is root 13 and OC is root 41 and R is 3, right? This is the maximum distance, right? All right, that's all for this video. See you in the next video, and we will do some more questions on set of points in an Argand diagram, right? Till then, bye, thank you, see you soon.